The FAQs for pre-calculus for section 5.4, day 1. Starting with number 12, and the instructions here say we are supposed to write this expression involving only the sine of theta and the cosine of theta. So what that means is we don't want the 2's in there. You know, we want something that doesn't have the double angle inside there, which would of course mean we probably had best be looking at our double angle formulas to see what we can put in here instead. So instead of the sine of 2 theta, we would put in 2 sine theta, cosine theta, using our double angle for sine formula. And then instead of cosine 2 theta, we would use 2 cosine squared theta minus 1. Like that S there. And what we're looking for here is now, do we just have theta? You know, there's no more double angle pieces in there. And there's nothing else that we can put together. So technically this one would be done as is. I mean, it doesn't seem to be, you know, simplified at all, but that's not what they asked us to do. It said, write the expression as one involving just sine theta and cosine theta. There's no double angles in any of this, so we have it. The next one on the list was number 16. Number 16, we are supposed to prove the identity, all right? So, I'm going to start over here with the cosine of 6x. Because right away I thought, you know what, we have double angle formulas that we could use for that. So it wouldn't be a bad thing to do to try and use the double angle formulas to get the left side of this. And since this has a 3x in it, I was thinking that, you know, 2 times 3x might be a good plan for that. So that's what I'm going to do. I'm going to use the formula and figure out what the cosine for the double angle of 3x would be. So this is going to be 2 cosine squared of 3x minus 1. And that's just from putting that into that double angle formula that we have. And that is exactly what they wanted. So when I saw the 3x, I thought, I better be using the double angle for the 3x formula. And then we just put it in and it's done. And to make it look exactly like they have, we could just take off the parentheses there. But that is just putting it into that double angle formula using the 3x. So the educated cheat is, you see the 6x, you know you have to get to 3x. That is definitely a double angle. Number 17, we have 2 cosecant of 2x equals the cosecant squared of x tangent of x. Now, we haven't done any with the secondary trig functions for these, so that makes me think that one of the first things I'd better do is write this using the primary trig function. So I'm going to start with the 2 cosecant of 2x because that is a double angle and I have formulas for that. And I'm going to see if I can't get to cosecant squared x tangent x by doing that. So with 2 cosecant 2x, I would write that as 2 times 1 over the sine of 2x, because that's what cosecant is. And then I'd say, you know what? I'm going to rewrite that sine of 2x using that double angle formula. That'll be 2 sine of x cosine of x when I do that. Well, something good just happened because now the 2's will cancel out. So I have 1 over the sine of x cosine x. I start thinking, doggone it, that's not going to give me what I need on the other side. You know, right now I can separate this and have 1 over sine x, which is cosecant x, and 1 over cosine x, which is secant. That's not going to give me what I need. So what do I have to get cosecant and tangent? Well, tangent would need sine in the numerator, and cosecant would need another sine in the denominator for this to work. Wait a minute. If I multiply both the numerator and the denominator by the sine of x, I will achieve exactly what I need. So this is another one where you do the educated cheat. You look ahead and think, okay, this looks like it's as simple as I can possibly get it, and it's not the answer that they wanted, so how do I make it be that? So this would now be the sine of x over the sine of x times the cosine of x. And what we would want to do is split this up so that this will work. Oh, actually that should be sine squared x down there. So we had sine times sine. All right, now what do we need? Well, we needed cosecant. That's 1 over sine squared x, because that will give us cosecant squared x. And then sine of x over cosine of x. Notice that if we multiplied that back together, we would have sine of x over sine squared x cosine x, which is exactly what we needed. But what we've done is we've now separated this, so this will be exactly what we were supposed to get, cosecant squared x times the tangent of x. So far, the questions that you've asked about, it seems like you're not thinking ahead to what it is you're supposed to get. You know, what is your end game? What are you supposed to see on the other side? And then you just do whatever you need to do to make that happen. So I'm going to go ahead and erase these and then start back up on the next problem. All right, our next problem is number 18, which is 2 cotangent of 2x equals cotangent of x minus tangent of x. And just like the last one, I'm thinking I want to start with the cotangent of 2x so that I will use a double angle formula and get this where I need to go. So the first thing I would do is rewrite this using a primary trig function, and cotangent is of course the reciprocal of tangent. And then the next place to go would be figuring out, you know, what does the double angle formula for tangent look like, and that is 2 tangent of x over 1 minus tangent squared x. Now, I would go ahead and multiply by the reciprocal, so we'd have 2 over 1 times 1 minus tangent squared x over 2 tangent of x. And that, of course, means that these 2's are going to cancel out. So I have 1 minus tangent squared x over the tangent of x. Now, do your educated cheat. Look ahead. What we need to get is the cotangent of x. Well, I already have that. That's 1 over the tangent of x. And then we need to get minus tangent of x. Well, I already have that too, because tangent squared x divided by tan x is going to be exactly that. So that's exactly what I have to do. I have to separate this. And we can do that just like we can add and subtract things that have a common denominator. We can certainly break them back apart. This would give us the exact same answer. If we simplify it, it absolutely will, because we would add those back together and it would be 1 minus tangent squared x over a common denominator of tangent x. But as we have it now, 1 over tangent of x is of course cotangent of x, and tangent squared x over tangent x is of course tangent x. So we have it. That's exactly what we wanted to get for number 18. So again, it seems like the piece that's missing here for the problems that have been asked for is that you're not looking ahead to what you're supposed to get for an answer. And that's, I call it an educated cheat, but it's really what you need to do. You need to think, once I've simplified this as far as I can, how am I going to get this to say what they want it to say? Now I'm looking at number 19 and I see there's a whole lot of stuff going on, but I have the sine of 3x. So I start thinking there has to be something that I can do with that that would break that down. And if it's sine of 3x, and I notice on the right side that everything is just in 1x, one of the things that I would definitely want to try is going back and using our addition formula for sine. So it's the same thing as the sine of x plus 2x. And then I remember that sine has the pattern of sine, cosine, cosine, sine. We do get to keep the addition with sine, but then we have to put in our x and our 2x, our x and our 2x, so we can see what we have. Now, I notice that we really have sine of x and sine of 2x going here, and that's not going to be good, so I need to figure out a way to get those two to be the same. And I have cosine of x and cosine of 2x, and that's not going to be good. So that's what my double angle formulas are for. So I look at my cosine of 2x double angle formula, and that will give me 2 cosine squared x minus 1. And I find my sine of 2x formula, which is 2 sine of x cosine of x. And I just want to see what on earth I have at this point. So at this point, we would have 2 sine of x cosine squared x minus sine of x plus 2, which way did I go before I did sine of x? Sine of x cosine squared x. So 2 sine of x cosine squared x minus sine of x plus 2 sine of x cosine squared x. Well, wait a minute. These terms are the same. So that will be 4 sine of x cosine squared x minus sine of x. Now let's go back and see what we were supposed to find. So for number 19, we needed to get this. The sine of x times 4 cosine squared x minus 1. So my last step is going to be factoring. I'm going to factor out a sine of x, and I have exactly what they wanted me to get for an answer. So simplified as much as I could, then took a look at what was I supposed to achieve here. What am I supposed to get for this answer? Breaking down any angles that have more than just theta or more than just x. If they have a 2x or a 3x, a 4x, a 6x, whatever it may be. Number 21, for 21 we have the cosine of 4x, and I'm going to go ahead and use the fact that I can break that down. So my first thought was, I think I'm going to make this the cosine of 2 x's, using that double angle formula. And if we use the double angle formula for cosine, we'll get 1 minus 2 sine squared of 2x. All right, well, now what should I do? Well, now I could go ahead and do some substitution for sine squared of 2x. So I'm going to go ahead and substitute in 2 sine of x cosine of x and square it. And you know what, sometimes that's just one of those things that's hard to see because, again, the sine of 2x squared is sine squared of 2x. And that's because I don't have an 8 yet. I needed to use some more numbers that might give me an 8. So this would be 1 minus 2. 2 squared is 4. Sine squared x cosine squared x. And we can certainly distribute that power of 2 because there is no addition or subtraction inside those parentheses. It's pure multiplication. And then we'll distribute the 2. And that gives us 1 minus 8 sine squared x cosine squared x, which is exactly what we needed to have. So a double angle formula to get the 2 involved in the system, and then using our sine squared to figure out, okay, I need the sine of a double angle. So this is, again, just keep thinking double angles here and breaking that down into those double angles. Number 31, I'm going to use the half angle formula, it says. So for 31, I think, well, half of what? Well, it'd be half of 30. So we are supposed to use the half angle formula for the sine of 30 degrees over 2, which is, of course, 15 degrees. So the first thing we'd want to do is say, okay, what's our formula? Well, our formula is plus or minus the square root of 1 minus cosine of x, it doesn't make any difference, over 2. So I'm going to go ahead and figure out exactly what is the cosine of 30 degrees, and hopefully you already have that one figured out by memorization here. But if we have If we've lost that information, you know, if it's just something we're forgetting right now for the unit circle, what you'd want to do is go ahead and draw your right triangle, your special right triangle, and think, okay, well, I'm looking at 30 degrees now, not 15 degrees, because I'm supposed to use this half angle formula. Well, then I'd want to figure out what the cosine is, and cosine is going to be the square root of 3 over 2. Like I said, hopefully, you know, you're remembering at least the first quadrant of the unit circle, and that one comes a little faster for you. So now, we do know whether or not it's positive or negative because it's 15 degrees. 15 degrees is positive. So we'll need 1 minus the square root of 3 over 2 divided by 2. And just like we did in class, we would go ahead and get a common denominator up here on the numerator, and that's really hard to see, but those are 2's. So 1 is the same thing as 2 over 2, so it'll be the positive square root of 2 minus the square root of 3 over 2, all divided by 2. And of course what we would do is multiply by the reciprocal. I'm not going to put that positive there anymore. 2 minus the square root of 3 over 2 times the reciprocal of 2, which would be 1/2. So that is the square root of 2 minus the square root of 3 over 4. And we can go ahead and separate those two because our denominator is going to be 2. So the square root of 2 minus the square root of 3 over 2, or the back of your book might very well pull that 2 from the denominator out in front and put a 1/2 in front. Again, that's mostly just to save on type space that they pull that out so they don't have to put fractions all over in the back. But either one of those would be correct. Then I'm going to erase and start number 32. Number 32 still has the same directions, and those directions are that we are supposed to use the half angles. So the first thing you do is take 195 times 2, and that would give you 390 degrees over 2. So we're supposed to use what we know about 390 degrees in our tangent half angle formula. So with tangent, what we have to do is 1 minus the cosine of x or u, whatever it may be, over the sine of u. So for the tangent of 390 degrees, I think about the fact that that's going to go 360 and another 30. So in first quadrant, everything is positive, and this will be 1 minus, well, now I have to figure out what the cosine of that 30-degree reference angle is. Again, you could make a quick little sketch if you've forgotten. So if we want the cosine of 30 degrees, then all we have to do is make the sketch or remember the unit circle, and that'll be the square root of 3 over 2. And we have to divide that by the sine of u, and the sine of u will be 1/2, because that's the sine of our 30-degree reference angle. And then it would be, oh, I don't want to skip any steps yet. 1 is the same thing as 2 over 2, so 2 minus the square root of 3 over 2, all divided by 1/2, and we are going to multiply by the reciprocal. And when we do that, the 2's will cancel out, and we will get 2 minus the square root of 3. So that formula we just hadn't made it to, and again, I'm not using the more difficult of the tangent formulas, just picking one of the other two to work through.